This is a study of the relationship between a CS1 student's gender and performance versus gauging understanding and study tactics. I am Kristin Stephens-Martinez from Duke University. So let's start with why did I do this study? Metacognitive monitoring is important. It's a student's ability to learn how much they know, and it in turn informs metacognitive control. The control is basically what we mean when we are talking about what a student is doing when they're deciding how to improve what they know. So the reason why metacognitive monitoring is important is because it helps a student learn. Another thing to note though is that these are skills, and therefore students can be good or bad at this skill, and students can get better at this. We can get students to demonstrate their metacognitive monitoring skill by having them predict how well they are going to do on an exam. And in this work, I had students do this prediction before and right after the exam. The reason I did this study was students often ask, as I'm sure many of you also get asked, how should I prepare for the exam? And I usually respond with the same advice of go through the course material and do the old exam without looking at the answers. So I honestly was wondering, are they actually taking my advice? And does my advice help at all? So my research questions for this study were, how accurate are students' predictions across the exams? Or are my students any good at metacognitive monitoring? Is the after prediction better than the before? Are they better at predicting what they are going to get after seeing the actual exam? Does accuracy improve over time? Or are they better at predicting on the final exam versus the previous exam? And finally, do groups of students study differently? Are there differences between high performers and low performers? Or are there differences between men and women? So I'm not the first person to come up with this idea. In fact, I decided to do it after finding a computer science education paper that already did this by Harrington et al. Called Gender Confidence and Mark Prediction in Computer Science Examinations at IDSE. So I went to find more related work, and I found 5 in psychology that were most similar to what I did. So what did they find? In broad strokes, their results are pretty similar to each other, and my results line up with everyone else's. But there's a lot of nuance in the results, and the devil is in the details. There was variation in when they asked students to predict their exam. Some asked before, some asked after, some asked for only some of the exams, some asked for all of the exams. There was variation in how they asked. Some asked with a simple text box, others used a multiple choice question, others asked in terms of the whole exam, and one even asked, per question, how confident are you that you're going to get this answer correct? And finally, there was variation in what units the students were asked to predict in. Some were asked, what percent do you think you're going to get right? Others asked, how many points are you going to earn? And others asked, what letter grade are you going to? So it was just all over the map. So this slide basically tells you everything. The first column is my particular research questions, the middle column is what the related work found, and the third column is my actual work. So in terms of how accurate are students predicting across the exams, generally they found that class performance correlates with accuracy, which is not too surprising. They found that better students are more likely to underpredict what they think they're going to get, and worse students are more likely to overpredict. They also found no gender differences. I found that students generally were pretty accurate, and only sometimes were high performers consistently better than low performers, and also no gender differences, which is nice to know. Is the after prediction better than the before? So high performers were accurate on both, so they couldn't really actually improve from their before prediction to their after. Middle and low performers do find some improvement, and really low performers do not improve. So in terms of my work, I found that my middle performers were more like high performers and that they were accurate on both the before and the after prediction. And then my low performers did have some improvement. Does accuracy improve over time? That actually really varied on the experiment. Some found that students did improve between their first exam to their last exam. Others found no improvement at all. In my work, I didn't see any differences. Finally, do groups of students study differently? This wasn't really something that people looked at in the related work that I found. But for myself, I found no difference, which was very surprising to me, and I'll definitely go into details of that in this video. All right, so let's go into the details of what I did. This is a 15-week semester for CS1 at Duke University. We collected data for spring 2019 and fall 2019, so this is pre-pandemic. And then we had 3 exams, midterm 1, midterm 2, and a final. And students could study from old midterms, but not old finals. For demographics, I really want to point out that there's some noticeable differences between the semesters. For spring, there were fewer students than the fall, but fall, while it had gender parity, about 50-50 between men and women, the spring semester had more women, while the fall semester had more students with prior coding experience. And then finally, when it came to racial minority, we had more racial minorities in the spring, but not the fall. I defined performance using only the exam part of their overall grade because they are the best measure what the students have mastered. Everything else is basically infinite time, infinite effort. They're going to get a perfect score. So it wasn't really useful as a measure of understanding how much the student knows by the end of the course. After defining what their performance was, I then split the students into thirds so I get high, middle, and low students. And to get a sense of how students perform generally, here are histograms of the exam grades. You'll notice that Spring 2019's Midterm 2 looks nothing like Fall's. And this was a surprise both for the students and for myself. I had not intended the exam to be that difficult. This unfortunately threw a wrench in a lot of the analysis. So how do we collect the prediction? For the before prediction, we released a 1-question survey 24 hours before the exam, and the students could submit whenever they wanted. And students earned 1 extra credit point on the exam for submitting, and it didn't matter if they were right or wrong. For the after prediction, that was the last question on the actual exam. And if they were correct, that's when they would earn an extra credit point on the exam. So there was a difference between how the students could earn an extra credit point between the before prediction and the after prediction. As for what the question itself was, we used a multiple choice question that was in 5% ranges. So we went from 0 to 4, then 5 to 9, and then all the way to up to 95 and 100%. And we did this rather than an open text box to avoid gaming the system for awarding points. In a pilot study, we told students that if they were within 10% of their actual grade, they would earn the points, which led to a lot of students calculating what 10% of the possible points were, and then subtracting that from the possible points and guessing that as their score. And this does mean that my results are in units of 5 technically rather than 1, so that's something to keep in mind for the rest of this talk. So we collected how students studied only for the 2 midterm exams. We did this because we collected the data as part of an exam wrapper, which we framed to the students as an exam reflection that they did after they received their exam grade. The point of the reflection was to have them think through how they prepared for that exam and how they should prepare for the next one. The only question relevant to this work was a checkbox grid question between the course material versus how they used it. Hopefully some of the course materials are self-explanatory. APTs are short problem sets. Reading quizzes are quizzes due right before lecture. It is usually just to check to see if they did the reading. Peer instructions are questions we actually asked in lecture. Assignments are multi-hour code assessments, and there were also old exams for studying. In terms of usage, they had 4 options that boiled down to 3 ways that they could have used the material. First is retrieval practice, which is where they did it for the first time, or they read the material without looking at the answers. There's review, where they reread or look at the material without necessarily quizzing themselves on it. And then there's finally did not use it all. And since students could have chosen multiple options because it was a checkbox, we chose to round up, which means, for example, if they chose retrieval and review options, we rounded it up to retrieval. So let's look at our research questions. First, how accurate are students' predictions across the exams? To understand accuracy, I defined a calibration score where we took the lower value of the range the student chose and the lower value of the range the student's grade fell into, and then subtracted the difference from 100. So that means the higher the value, the more accurate the student was. And if, for example, a student guessed the right range, their calibration score is 100, and if they are off by 1 range, either up or down, the score is 95. This box plot shows you the spring and fall semester and their calibration scores, and you can see that overall, the students were pretty accurate, within 10% of their actual grade. And the median for all of these is actually 90% or higher. When comparing based on performance, this time I just plotted the difference between the predicted and the actual range. And reminder, performance is based on only the student's overall exam grade, and each group is a third of the class. These line graphs show the median and the confidence interval for the before and the after predictions. And I use the median instead of the average because the distributions are really skewed, and the median better shows the central tendency of the dataset. So to read this graph, we can see that for Spring 19's Midterm 1's low performers, which is the blue line, their median prediction was 15 over their actual score. And the confidence interval tells us that quite a few students were even potentially 20% over their actual score. And when we're looking at this graph overall, we can see that generally low performers are worse than middle and high performers, and middle and high performers are more similar than different when it comes to their ability to predict. We can also see from this graph that students sometimes improve from the before to their after prediction. When we ran statistical tests to understand what was going on between the before and after predictions, we did see that across all students, there is some improvement from the before prediction to the after prediction for earlier exams, but not necessarily for the later ones. We also saw no gender difference. For the high performers, they did not really improve between the before and the after, which isn't actually that surprising because if they predicted well on the before, they can't really predict better on the after. For low performers, they sometimes did improve. So does accuracy improve over time? If you recall the slide from related work, the answer is no. And to put that into more context, given I just said they do improve from before to after, when we consolidated the before and after predictions into a single prediction, we saw no improvement between how good they were at the first exam versus the later exams. Though this is potentially due to the spring semester's midterm 2 being extra difficult. So do groups of students study differently? So as I said before, there's no difference. So my students are using my advice, but the advice isn't helpful? This surprised me. My best guess as to what is going on is I collected the wrong data. I asked students about cognitive strategies. What are the activities the students are doing when they're studying, rather than what concepts they applied these activities to. There's so many different variations that a student could be doing when it comes to these activities. They could be choosing what topics to be studying, there could be variation how long they're studying a particular topic, or in other words, the low performers could be doing what they should be doing, but they're just going through the motions without being mindful of why they're doing what they're doing, which means they aren't actually getting much out of the exercise. So let's talk about some threats to validity. First, there's a prediction ceiling effect. You can't really predict over 100%, so in some ways it's not surprising that the higher performers are more likely to underpredict because they can't predict 110%. That means that the accuracy improvement is sensitive to the space to improve. So there's more room if the calibration score is 80 compared to 95 for a student to improve their accuracy. There's also the extra hard spring 2019 midterm 2, which kind of threw a wrench in everything, as I said before. And study tactics are self-reported, which means that rather than reporting what they actually did, they more reported what they aspirationally thought they should have done. So that's something to take with a grain of salt. So if you remember at the beginning of this talk, I discussed how I wanted to understand if my students were any good at metacognitive monitoring, because that affects their ability to learn, and whether they were following my advice to study, and if that study advice is any useful. In terms of the metacognitive monitoring skills, I've learned that, first, they're pretty good at it. They had a 90% or higher calibration when it came to predicting their exam score. There's no gender difference, which is nice to know. Better students are better at this skill, which is not surprising. And seeing the exam often leads to a better prediction. So they improve from the before to their after. And time does not improve this skill. And in terms of whether or not time improves in this skill, that just probably means that there's nothing in my course that really helps the student learn how to be better at this. As for how they are following my advice on how to study, yes, they're following my advice, but no, it's not helpful, though I think more digging is required there. And all of this has a caveat that results are not clear-cut and there's lots of nuance. Please see the paper for more details. And with that, I look forward to answering your questions.